Hi, my name is Jason Zahorak, student ID number G000357778. I am here to present you my final capstone project. I chose to design a digital fuel level indicating system for an M978 Hemet tanker for the United States Army. During this portion of my project, I will be conducting the circuit operational testing. Keep in mind I was unable to acquire 3.5 digit analog digital converter, and I did not purchase the ultrasonic sensor due to financial issues. To simulate the ultrasonic sensor, I will be using a potentiometer to develop a 4 to 20 milliamp input to the circuit, which would be the output of the ultrasonic sensor. And the signal conditioning circuit should provide a 0 to 2 volt output, which would then go to the 3.5 digit analog digital converter, which will power the 4 7-segment LEDs to display the fuel quantity. Here I have a basic 5K potentiometer hooked up to a 9-volt battery and a digital multimeter. This will be used as the input signal simulating the ultrasonic sensor, providing the 4 to 20 milliamp current to the signal conditioning circuit. As I turn the potentiometer, as you can watch the current vary from 4 all the way up to 20 milliamps. And this will be used for the operational testing to test the signal conditioning circuit. Here is my circuit set up, prepared for the circuit operational testing. Like I explained earlier, here is our simulated ultrasonic sensor, which will provide the 4 to 20 milliamps to the signal conditioning circuit, which is right here. The first yellow wire on the left is the input to the op-amp signal conditioning circuit, and this will be the output, which will be measure the voltage on the digital multimeter. Like I said, the voltage read on the digital multimeter would be the voltage which would be the input to the 3.5 digit analog digital converter, which would power the 7-segment LEDs up here to display the fuel quantity. I will now do the operational testing by varying the potentiometer from 4 to 20 milliamps to provide the 0 to 2 volt output. With the potentiometer set at 4 milliamps, my output is 0.2 millivolts instead of 0. With the input set at 4.8 milliamps, my output is 102 millivolts instead of 100 millivolts. With the input set at 9.6 milliamps, the output should be 700 millivolts. I have 688 millivolts. With the potentiometer set at 16 milliamps, my output voltage is 1.74 volts. Should be 1.5. I have completed all of my operational testing for all the test points for my signal conditioning circuit. My conclusion is the circuit is operational within 0.5% of the required results for most of the test points. However, one test point did come up with a 2.7% error from the result when I had it set at 16 milliamps. I should have received a 1.5 volt output, and I received a 1.475 reading. I will submit my final operational test document with this video.